Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to talk about how to calculate the number of photons that corresponds to a certain amount of radiant light. So let's get into this. So here in this problem we're given that the retina of a human eye can detect light when radiant energy incident on it is at least 4.0 times 10 to the negative 17 joules of energy. For light of 600 nanometers wavelength, how many photons does this correspond to? Okay, so how do we attack this problem? So the first thing we need to recognize is that what we're given here in this amount of energy is a total amount of energy that is falling upon the retina that is required for you to be able to detect the light and be able to see something. Okay, so this is a given amount of energy that's required in joules. Okay, and so we have to understand that that given amount of energy of light is not just one photon, but a whole bunch of photons that are falling upon the eyeball and the retina. And so we need to first understand that. Second, we need to find the amount of energy in one photon, and that's where the 600 nanometers is going to come in, because that's going to be the wavelength of light, and we can use that to calculate the amount of energy in one photon. So let's go ahead and do that first. So the first thing we want to do is convert nanometers to meters. So start with 600 nanometers over 1. I know that 1 nanometer is equal to 1 billionth of a meter, or 10 to the negative 9 meters. So I'm going to use that as a conversion factor. So I'm going to put 1 nanometer on the bottom and 10 to the negative 9 meters on top. So nanometers cancels out. Now I have meters. So I'm going to calculate this. And when I do, I get 6.00 times 10 to the negative 7 meters. So now I have my wavelength in meters. Now I can convert this to energy. I'm going to use the equation. The energy of a photon is going to be equal to hc over lambda. I'm looking for lambda, which is the wavelength. H is the Planck's constant, and c is the speed of light. So I'm going to rearrange this to solve for the wavelength. So that's going to be wavelength is equal to hc over the energy of a photon. So now I can plug everything in. So Planck's constant is 6.626 times 10 to the negative 34 joule seconds, multiplied by the speed of light, which is going to be 3.0 times 10 to the 8th meters per second, divided by the energy of the photon, which is what we have here. Oh, my bad. I forgot what we were looking for. We're given the wavelength. So we're not solving for wavelength. Sorry if that confused you. So we got wavelength. We're going to solve for the energy of the photon. I forgot what we were doing. Okay, so then I'm going to put the wavelength down here. So I have 6.00 times 10 to the negative 7 meters. Okay, sorry, I had a Biden moment. So now I can start to get rid of the unit. So I can cancel out the meters. Meters are going to cancel out. Seconds are going to cancel out. And now I have joules. So now when I calculate this, I get, what do I get? I get 3.313, 3.313 times 10 to the negative 19 joules. Let me double check that again. That is correct. So this is the amount of energy per photon. Okay, so now that I have the energy per photon, I can now use this to calculate the number of photons in this amount of energy. So I can use this as a conversion factor. So here, I'm going to start with the given amount of energy. So the total amount of energy is 4.0 times 10 to the negative 17 joules of energy over 1. And now I want to convert joules of energy to number of photons. So here I have the relationship of joules to photon. So I can then put joules on the bottom. So I'm going to put this many joules on the bottom. So 3.313 times 10 to the negative 19 joules. And then 1 photon on the top. So joules cancel out. I have photons. So now all I need to do is multiply and divide. And when I get that, I get 1.21 times 10 to the second photons. So this is the number of photons that is needed to be incident on the retina if the wavelength is 600 nanometers. So this is your answer. So I hope that was helpful. If you enjoyed this video, if you like this video, then please, by all means, like the video, share the video. Also, make sure you hit the like button somewhere around here, over here, I think. Finally, well, not finally, but remember, subscribe to my channel. Help me out. Hit that notification bell when you do. Make sure you click all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question you need help with or a topic you would like me to cover, just put that down below and I will do that for you. Thanks for joining me and have a great day.